Easy one today. So let's try to do this pretty quickly. Count good triplets. Given an integer array and three integers ABC, we need to find the numbers of good triplets. Triplet that is array I, array J, array K is good if I, J, K, the indices of those values are in successive order, and the value I minus value J is less than A, less than or equal to A. Value J is minus value K is less than or equal to B, and value I minus value K is less than or equal to C. Okay, so A, B, and C are like how far apart the values at those various indices are. A is for the first two, B is for the second two, and C is for the first and last. So find the number of good triplets. So if the difference between the first two is less than or equal to 7, second two is less than or equal to 2, and the last one is less than or equal to 3. So like 3, 0, 1 works because 3 and 0 are less than a difference of 7. 0, 1 is less than a difference of 2, and 1, 3 is less than a difference of 3. Similarly for the other ones. 0, 0, 1, so the first two have to be the same, or actually they're all have to be the same really, right? First two is the same, second two is the same, so therefore the third one, that doesn't really matter. But there's no triplets that are the same. Okay. Okay. Seems understandable. Alright, I'm gonna try for a sliding window approach. How would this work here? Sliding window would work if So A is the difference between the first two. A is the difference between the first two. How big are these values? Okay, this is pretty short. Only 100 long. No. Yeah. So I could try for a simple, let's try like an n squared n cubed approach for I in range of n. N being the length of the array. And then for j in the range of anything after I. And for k in the range of anything after j. We'll just say we're going to return the number of them. So if the absolute value of value I, or array I, minus array at j is, well, that's going to be the same for the outer loop here, so for this inner loop. So I could possibly just stop it here. If A is bigger than absolute value of array I minus array j, then just ignore this possibility. And then this one only works if the absolute value at array at j minus absolute value array at a is less than or equal to b, and also the absolute value at array at I minus array at k is less than or equal to c. Increment the answer by 1. I think that is fine. So once you've identified k, you need to check for both the other two constraints. And I think that's it. Return the answer. What did I do wrong here? This probably is wrong right here somehow. If A is bigger than the difference between the... No, this seems fine. A is... If this thing is less than the difference between B and this thing is less than the difference between C, I goes from something to N, J goes from something after. I, J, K are in order. K is after J. Okay, so let me go ahead and see what is being evaluated at this point. Okay, so 097 is the first thing. So it's not the 301 that should work. Why doesn't the 301 show up here? So the first thing is I, and here A is 7. Okay, let's see. So this thing should be not okay for a lot of them. So 30, why isn't that not okay? So 7, 7 is eighth. If 7 is bigger than 3 minus 0, seven is bigger than 3 minus 0. That's I'm doing this backwards. No, okay, yeah, this is backwards. If A is less than or equal to the difference, because if A, so if this thing is less than or equal to the other one, so normally the logic is this thing is less than or equal to A, but negation of that logic should mean that this thing is bigger than A. Okay. Okay. Let's see how slow this is. Alright. I think that's pretty reasonable. Guess there was something very, very slightly faster, but can I change this at all? I in the range of n, j in the range of -1. Stop early if possible. K in the range of that. Yeah, I think I'm fine with this. So summary, this is a go through every triplet. No real optimization. Where outermost loop iterates through indices for I, middle loop iterates indices for J, which come after I, start at I plus 1 to not overlap. And innermost loop iterates through k. Middle loop um, can shortcut impossible comparison for difference of value at I versus value at j needs to be less than or equal to a. Otherwise, skip over those indices that occurred at this if statement there. And then inner loop needs to check the other two constraints for B and C. Time analysis, this is going to be O of n cubed, since each loop iterates through values of n. And then space analysis, this is just O of 1, no extra data structures, just variables.